Hello class, this is Dr. Hux. We're on Module 9 and this is truly a brief overview. You're going to do multiple regression. That's out of Chapter 12. And of course project, you're going to write up a treatment of the data, a plan for that. Multiple regression identifies variables that predict continuous outcomes. And there you see the chef, I guess that's me, treating the data. Module 9 objectives, the ones that are really important, number 1 and 8, and number 2 takes a long time. That's what I have to tell you about that. Determine how and when to run a multiple regression analysis. And number 8, provide a plan and rationale for the treatment of the data. Now, number 2, verify that the data meet the criteria for multiple regression processing, things like sample size, linearity, homoscedasticity, and multicollinearity, and normality. I can't even say those terms. They're so complicated. Multiple regression. Primary goal of multiple regression is to build a mathematical model. That's going to be an equation, one that provides the most explanation of the outcome variable with the fewest predictor variables. It produces an equation and correlations. That's what multiple regression does. We usually sometimes refer to it in writing as MLR, multiple linear regression. See this top equation here with y hat on it, and it looks like a linear equation. You don't see any variables squared there. You see a b sub 0 variable, and then you see coefficients x, in your simple linear regression, you just worked with this part right here, the first part of this thing. But in multiple linear regression, we add on more linear terms. And the variables, the predictor variables, that's what they're called, are the x values. And the x values will take on numbers like number of cigarettes you smoke each day. That could be this one. Sugar intake, that could be the next. Income level, that could be another one. And you could put in the codes for gender, male, female, age, race, etc. The B1, B2, B3, the B values are the predictor coefficients, Now, they usually take on values like 0.206, 1.35. They usually won't be very large, or even a negative number. The b sub 0 is basically the y-intercept of the equation. You remember it from algebra, y is equal to mx plus b, where m was the slope. Well, in our case, the slopes are the b values, and the b sub 0 is the y-intercept. I always think that somebody was on alcohol from their algebra class and got into a statistics class and tried to set this up and forgot what the B's and A's and M's were supposed to be. Here's what the equation could look like right here based on the results you're going to get from your multiple linear regression. In other words, y hat, the dependent variable, whatever it is 0.531, and then you have all these. If this was the number of cigarettes you smoked each day, you'd put that number in there. If this is your sugar intake, you'd put that measurement in there, and so on and so forth. And actually, here's the table you're going to get when you run the multiple linear regression. And you'll notice up here, I've got that same equation, and I scratched out this last variable because when I did that, the first time I failed to look at the table completely. But here we have the predictor values, 0.531. That first one that'll line up there is going to be the y-intercept. Then your next variables are going to be the coefficient variables of the predictor variables. And look what happened over here to 0.004. Its probability, the significance, was greater than 0.05. So I didn't notice that at first, and I put that equation together. It tells you what the predictors are. So simply, you're going to run this test and get this table and make an equation that looks like this. That's the bottom line for multiple linear regression. There's a lot more to it, but that's it. Now, this is pretty complicated as far as understanding all the pieces that go into it. The SPSS going through the procedure is almost a nightmare. I hate to tell you something like that, but it is. So you need to look closely at the videos I've provided and the PowerPoint for this lesson, the PowerPoint that the textbook puts out, because you will want to go back through that. So when you get ready to do your homework, open up that PowerPoint on the side so you'll know what step to take first, second, third. Now, what I've done, you have to do problems 12.2a and 12.6a. They're both similar. There are no tricks to them. But what I've done is set up a template for you to follow. And all the yellow places, you have to fill these in. You fill in the yellow pieces. And like you write your null hypothesis, your motivated hypothesis, and then you'll fill in the variables. Even in the first one, 12.2a on the template, I've got all this filled in for you. But I wanted to give you an idea on the second one. You're going to have to fill in your own. This is not difficult to do, but you just have to work through the process to get there. Here's some graphs. I've got all those for you. You can be able to check your work straight up on this thing. But even right down to determining if it was normal. You know, you have some pretest conditions. About the only thing you have to do when you're finished to make this work is cut and paste your table right here. That table we just looked at in the first couple slides there. Look, I've left a yellow spot out here, so you'll have to take care of that anyway. But anyway, let's go to the next slide. So in multiple linear regression, here's the video that the text provides. Now the PowerPoint probably gives you more information, but here's the video that tells you how to run through this thing. And again, it's not difficult, it's just long and involved. If you think simple linear regression might have been difficult, well, take a look at this. But anyway, let's go on. This is a training, I call it the training video. Now, I felt like you needed more help than their video might provide. So what I've done, and I suggest you do this, is watch part 1 and part 2 here, these videos, actually before you even watch theirs. These are about 20 minutes long. I'm telling you, this is involved. But watch these 2 videos first, then watch theirs. Here's a few more, and they're really nice. If you want to know more about it, it talks about dummy variables. That's what I am, I suppose, the categorical variables. And the reason I put this here is because if one of you try or decide to do this in your dissertation, you know there's more to it than what we're going to superficially look over as we do this assignment right here. And these are the things. So you might want to come back to these someday. You may want to cut and paste this somewhere and save it so that you can come back to it very easily. Now the course project. It's kind of simpler this time, is to provide a plan and a rationale for the treatment of the data as a portion of your course project. Now, what you can do is just look at some dissertations that I've given you, or just Google. You know, Google's my favorite place to go to. You can find out lots of stuff on that Google. Anyway, you're going to author a section called Chapter 4 called Treatment of the Data. And that's going to be important. You're going to put it in Chapter 3, and you're going to put it in Chapter 4. I don't think you put it in Chapter 1. It's not in there. But anyway, this will contain a discussion of how you plan to procure, manage, process, and analyze the data. It's what you're going to do with the data once you get it. See, you're even going to talk about how you got it, how you got the data in this particular narrative. This is a narrative process. Don't set up an outline format for this. This is narrative. The instructions will tell you all that. As you introduce your plan for the treatment of the data, you will basically respond to how, when, why, and where of things. Kind of like writing a press release, but it'll be a narrative format. Okay, good luck, my friends.